Hello, calculus students and general seekers of truth. We end up with one more example here of improper integrals, and we're going to evaluate this one from 0 to infinity of x e to the negative x. And as before, we are going to take the limit as b, or whatever variable you'd like, approaches infinity of the integral from 0 to b of x e to the negative x dx. So now we are going to evaluate this antiderivative, and we're going to do this using integration by parts, because this antiderivative cannot be done in other methods. I'm going to use f as I'm going to use x here as my f function, and e to the x here as g prime. Okay. So this becomes f times g. So f is x. G is the antiderivative, so that's e to the negative x, negative, minus the integral of f prime, which is just 1, times g again, which is negative e to the negative x dx. Okay. And keep in mind that we are evaluating this between 0 and b. So once this is all done, right, once all of this is done, then we are going to plug 0 and b into it in the end. And of course, we are taking the limit of all of this as b approaches infinity. Okay? So I'm not going to put these limits of integration in here right now, unless there was some discontinuity here. In this case, there's not. So I'm just going to leave it out here. Once I'm done with everything, then I'm going to plug it all in. Okay? So this is the limit as b approaches infinity of negative e to the negative x e to the negative x. This is minus the antiderivative of negative e to the negative x is positive e to the negative x. And then this is all evaluated between 0 and b. So let's make our substitutions. We end up with negative b e to the negative b minus e to the negative b minus, when I plug 0 into here, I'm going to get 0, and then negative e to the 0, which is just 1, and we're taking the limit of all of this as b approaches infinity. This becomes positive 1, so this is negative b e to the negative b minus e to the negative b plus 1. Okay. So we need to plug in all of the values for b. Okay. Now a weird thing happens when we plug in infinity for b, because e to the negative infinity is 0. This is e to the negative infinity, that's 0. Times, and we take infinity and plug it into here, we end up with infinity again. So it's a little bit weird. You have infinity times 0, and that itself is also another indeterminate form. But let's just convert this to something that we're more familiar with. So this is negative b over e to the b, okay, minus 1 over e to the b plus 1. Now this plus 1 here is pretty much irrelevant, and all I'm really going to do here is put these two fractions together. So we end up with negative b minus 1 over e to the b plus 1. Oh, and I forgot, we got to take the limit as b approaches infinity. Okay. So you can see that if we were to plug in infinity, we would get infinity on the bottom, and we would also get infinity on the top. Okay? So that would be an indeterminate form. So we're going to use L'Hopital's. Use L'Hopital's rule. Take the derivative of the top, and that just gives us -1. The derivative of the bottom, which will give us e to the b, and we're going to take the limit as b approaches infinity. So now, and this 1 again here is irrelevant compared to, well, it's not entirely irrelevant, I'm sorry. We're going to leave this, take this limit as is, because this 1 here is just something we're going to add on at the end. And you can see here that the limit of this thing, as b approaches a very large number, this is all going to approach 0. So the answer to this is also 1. And so there you have it, an example of improper integrals using the application of L'Hopital's rule. Thank you for watching, and have a wonderful day.